This video is an overview of EnergyPlus, and I should say a very brief overview, but the things that will be covered are history and predecessors to EnergyPlus, whole building simulation and what that means, because that's what EnergyPlus is, and the learning resources for EnergyPlus. So let's get started on the first one, the history and predecessors to EnergyPlus. EnergyPlus was a combination of the code from two previous building energy modeling softwares called BLAST and DOE2, which were both written in Fortran 77. Because EnergyPlus was a combination of these two softwares and they were quite old, the Fortran 77 legacy means some model components are limited. For example, surfaces and zones must be convex for some lighting and shading features to actually work in the building model. There's a lot of redundantly connecting equipment together in air loops in multiple places, and air loops and plant loops have a specific topology. You can't really deviate from that topology or the model just won't run. EnergyPlus 1.0 was written in Fortran 90 and released in 2001. Fortran 77 is a subset of Fortran 90, so it was easy to translate to Fortran 90, but it still took years to combine the BLAST and DOE2 code. EnergyPlus was released under a permissive open source license in 2012. Prior to that, there was a different license that was more restrictive. So EnergyPlus is now open source software using a permissive BSD style license. That's Berkeley Software Distribution. EnergyPlus 8.2 simulation code converted to C++ from Fortran 90 by Autodesk in 2014. However, there are still remnants of Fortran 77 you can find if you dig around the EnergyPlus code, like the Fortran 77 maximum of 6 characters for a variable name, which makes some of the code a little hard to read. So that's a brief history, so let's continue to the next topic. EnergyPlus is a whole building simulation software, so what does that mean? As an example, this is a prototype model called the Medium Office, and it was released by Pacific Northwest National Lab, PNNL. Formerly it was a DOE prototype model, but they did, upgrade it every few years. So the first thing to notice is the windows. So rather than having a bunch of individual windows in the model, they just have one long strip along each wall, and then the surface area of that entire strip is going to be the surface area of all the individual windows combined. That makes it a little easier to simulate and also for the modeler to actually specify pretty much all the windows in one giant window, and it doesn't really make a big difference in the energy use. EnergyPlus models use thermal zones rather than rooms, actual rooms. And one thing is the thermal zones have uniform temperature throughout them in the entire time step. Every single point in the room is the same temperature. There are some settings you can change in EnergyPlus, like having stratified air temperatures within a zone, but for the most part, everything's uniform. Here's the Medium Office tilted a little bit, and I took off the top floor ceiling plenum as well as the ceiling of the third story. The red dots you see are daylighting sensors. Based on how much light is coming in through the windows, it will control some of the lights in the zone to dim them or turn them off. You can see this is a pretty simple model of a building, so it has 4 trapezoids, one along each wall, exterior wall, then it has a big central region. The thermal zones are set up so that these different pieces of the building, which experience significantly different loads, are all modeled correctly. So right, if the sun is shining in on one side of the building, it's going to have a significant load from the sunlight going in, and then maybe on the other side it's going to have less, and then the other 2 sides they might get some sun, and so they'll have a different load. The interior of the building, if the 4 boundaries are being conditioned correctly, essentially has external boundary conditions that are at the set point temperature for the entire building. So they experience a very different load than the exterior zones. You'll notice there are no elevators or stairwells. There are no conference rooms that get really cold and then are stuffy when it's actually in use. There are no bathrooms. You also have uniform surface layers. What that means is if, let's say, you had a wall that was stucco, and then on the far other side it was wallboard, and then in between you had bad insulation next to 2x4s. The stucco would be one layer in the construction. Another layer would be a layer of drywall. but then the middle layer would actually be uniform. You would kind of average out the resistance value of the 2x4 with the bad insulation to make one averaged material. Sometimes modelers don't realize what whole building energy simulation really means, and they say, well, we need more accuracy. We need, to model this building better. So what if you do need more accuracy? So all at once, there's another type of software called ESPR, and ESPR models a particular building. You can see in the right image there, it's very detailed. You can put in the doors, the bookcases, the chairs, the windows, the seams in the windows, shading surfaces. It can model the gaps in doors, it can model the cracks, it can model everything. But then if you're going to go to that level of detail, you better also specify all the ducting. What's the path it takes through the entire building? And if you're going to go to the trouble to specify all the ducting, you might as well specify functions for the pressure drop and loss at every connection in the HVAC system. If you're going to go to that level of detail, then you can actually use CFD, computational fluid dynamics, simulations for all air in the model. And for instance, that includes things like thermal plumes from people or computers and anything else. So right, this is going to be a really good model. It's going to model a particular building, and it's going to be very labor intensive to make. Now I know what you're thinking. Maybe EnergyPlus is, good enough, right? Kind of a joke, but EnergyPlus is whole building simulation. So rather than modeling a particular building, it is modeling a representative building. So this is a 3-story medium office, and you want this building to apply to a bunch of buildings all over the world, or, continent, whatever. EnergyPlus is actually quite accurate, despite all the approximations. I think some of the estimates that have been done, it can be about 1.5% off in cooling and 1.5% off in total heating energy use. One of the benefits of being based on code from quite a long time ago, those computers were quite slow. So the EnergyPlus simulation engine is pretty lean, it's pretty quick, and it gets good results. And the purpose of a model like this is to test a change in multiple locations and climates for savings. So let's say you're investigating a new roofing material. You don't care if that roofing material works for a particular building. You want to know if it works for all medium office buildings, or at least most of them. And so that is what this is. EnergyPlus makes a whole building simulation, and you use a representative building model to try and model a whole bunch of different, slightly similar but different buildings all at once, and evaluate, is this technology good? Is it going to save either the consumer or the state or the environment or the power grid? Is it going to be a good investment? So once again, EnergyPlus is for whole building simulation. If you want to do a really detailed model, then you're better off using something like ESPR. And you're going to have to pay for that accuracy by the amount of detail you're going to have to put into the model. Moving on, there are some learning resources for EnergyPlus, but I would say there's not a whole lot. The first one is unmethours.com, which is an EnergyPlus forum. I think it started in 2014. It's more of a place where if you get stuck on a weird error or how to do something unusual, then you can ask and people usually answer. It's not great for learning from scratch, though. There are some resources in the EnergyPlus installation directory. The first one is the example files directory, and that's no space in between example and files. In that directory, you have a bunch of IDF building models, and usually they'll show you how to use a particular object class in a simple building model. So you can study that and then figure out how to take that particular object you want to put in your model, and you at least have a template or an example to work with. There is also the documentation directory, which has a bunch of PDFs like getting started, the input-output reference, and others. The input-output reference is more like a reference. It's a little hard to learn from, but it's probably the best one. You also have YouTube videos like this one, and there are others. Please consider watching them if you thought this was useful. And lastly, you can pay for training from a company. So there are a few. Well, hopefully you found this useful, and you have now decided whether or not EnergyPlus is the right software for your project. And now you can continue and start learning how to use it from some more examples.